So in order to talk about organizing information on the web, the semantic web, we need to back up a little and talk about just a couple of more standards. This is going to be a real high-level overview. I'm not going to go into a lot of detail, but I think I can get across the object of what's going on here in a fairly simple way. But know that I'm leaving out a lot, and this is a pretty high-level overview. The first standard I want to talk about is Resource Description Framework. And Resource Description Framework is actually a conceptual language for representing information about resources in the World Wide Web. And it's a language that is specific to machines being able to interpret or separate out the different parts of the statement that you might make about a resource on the World Wide Web. And so it's based on really three very simple things. It's the notion that anything on the web is identified by what we call a URI. A URI is a Uniform Resource Identifier. You may be thinking of URL, Uniform Resource Locator. That's one way to identify things on the web. There are a couple of other ways. There's Uniform Resource Name. And all of these together we call Uniform Resource Identifiers. You can think of it as a URL. Most examples are going to turn out to be URLs, so I don't want that term to be confusing. So anyway, we have the idea of identifying a resource that has a Uniform Resource Identifier on the web. And then we talk about those resources in terms of properties and property values. And the way that this is done is through what's called a triple, the RDF triple. And it's just simply a way of saying that a resource, the subject, has a property, which is a predicate, of a specific value, which is an object. So we have subject, predicate, and value. And let me give you an example of that here. So in English, I might say the author of the web page is John Smith. And it turns out that that's not, while it's very understandable to us, it's not particularly understandable to machines. And so RDF says that the proper way to express that is to break this into the subject, the predicate, and the object. And so the subject here is actually web page. Web page is the resource that we're talking about. The web page is identified by a URI. The predicate that we're talking about is the property that we want to get at. In this case, we want to know who the author of the web page is. So author is the predicate. And it turns out that the name of the author, the value of that predicate is John Smith. And so we have a subject, example.org/index.html, that's the subject, has a property called creator, that's the predicate, and if you'll recall, that's a Dublin Core term, whose value is John Smith. That is, John Smith is the name given to the creator of the subject, the resource page. And so that's the idea of RDF in a nutshell. It's just a particular way of expressing it. You can think of it as syntax, if you like. And it turns out that this happens to be useful for machines. It's often expressed as a graph. RDF isn't inherently expressed in any particular language. It's a descriptive framework, and so it's actually kind of English-based when you read about it. And it's often in that context expressed as a graph. So let's break out this example that we've been working on just a little bit farther. You can see down here we have a kind of a green blob with a subject at the top. We have an arrow pointing down to another URL, and that turns out to be the object. And then we have a line pointing from the top to the bottom, and on that line is another URL. And that may look a little bit confusing, but let's break it down. So the first green blob at the top is the subject, and that's the particular web page that we're talking about. As we go down, we see the URL next to the line. Recall that Dublin Core actually is a schema that defines 15 elements, and one of those 15 elements is the creator. So we can actually refer to the place on the web where the Dublin Core schema talks about the actual attribute of creator, and that's our predicate. And then the object, here's another URL, which again may be a little bit curious, but it turns out that may be the URL that describes or has information about John Smith. And so this is the way RDF begins to link information in ways that computers can understand it. Let's take a look at a little bit more extended version. Of course, the top green blob at the top, and then the middle one are what we brought over from the other page. In this case, the second green blob is the object, the website that describes this particular person, and that website might also contain literal values. John Smith is the particular name, and again, notice the RDF triplet when you look at the second green blob as a subject. Then the predicate here is the name contained within that particular website, and the value of that name is John Smith. And then there might also be other information. His age on that website might be listed as 27. So again, this is the way RDF continues to expand down as you go into information. It turns out to be that this is pretty useful for machines. We extend RDF actually, which is a conceptual language or conceptual description with a particular schema that defines some specific predicates or defines some specific things that are relations between subjects and objects. And so there's a list of terms and relations. These include class, property, type, subclass. There are several that are defined here. Not really important for you to remember those in particular, although if you do want to get some more details and examples about RDF and how this all works, then you can take a look at this link here on your own time that will go into a little bit more detail on that. So the second term that I need to bring into the picture before we get to the semantic web is the term ontology. It turns out that this term is actually kind of used loosely in various contexts. In the context that I'm going to use it, this is high-level subject classification. So in much the same way that you have your list of terms, your controlled vocabulary, such as Library of Congress subject headings, or you have the art and architecture thesaurus, or you may have heard some other terms about different kinds of subject classifications, synonym rings, and so on. The ontology is really usually put at the top of the list in terms of complexity, and it really is what exists in the world and how is it described. And so it's usually formally describes a knowledge domain. It's a way of talking about a specific area of knowledge. It can be broad if you want to know all there is to know about everything. That's sometimes called an upper ontology. Most ontologies are narrower than all about everything, so we might have an ontology that just describes pizza, and it tells us everything we need to know about pizza, all the different objects that comprise a pizza, how they're related, what their names are, and so on, and that would be an ontology. Now, of course, a web ontology then is an ontology of things that exist on the web. That's probably easy enough to figure out. And then we've developed several different languages that allow us to express ontologies about the web in particular, and these are there are several of them. I'm going to talk about OWL, which is a web ontology language. You might think it would be WOL, W-O-L, for web ontology language. They just decided that OWL was easier to say, and that's the only reason for it. But OWL is a particular language for creating web ontologies, and it turns out that OWL uses the RDF schema in order to do that. Now, at this point, it might be confusing you a little bit, and it really is simpler than you might think. So probably a demo is in order. So here, and this actually may look fairly complex, but it's not. Let me point out some of the different sections of this. This is an ontology of a pizza. This is going to tell us what a pizza is, what are the component parts of it, and so on. And this is being created in an ontology editor. This particular ontology editor is called Protege, and Protege is an ontology editor that can use the web ontology language to create this. And so all I did to create this, really, the top level in ontology is always a thing. The thing that we're going to describe is the pizza. We have a few different classes of objects. We have the pizza, of course. We have pizza base. Pizza is made out of a pizza base and a pizza topping. Pizza base might have a couple of classes, deep pan base and thin and crispy base. So those are a couple of different bases that you can have with pizza. As we go down here, you can see the different kinds of toppings, how are these described, and so on. And so this is just really a kind of a hierarchical view of a pizza. We can take a look at the properties. Remember, we talked about the predicates, those things that relate subjects and objects. And so we have a few properties here. So we can say certain portions of the pizza have ingredient, pizza has a base, pizza has topping. So these are different properties. And we can also take a look at the visualization here. And the visualization now begins to put this in that RDF kind of context where you see the RDF graph. You can see that over here on the right. Here are the subjects, the predicates, the objects. You can see the chain as it goes through. We can scroll through this ontology and see how all these different things relate to each other. And so this is the visual representation and the kind of schematic hierarchical list of the ontology that we've got. And now let's take a look at what actually is all underneath that. What's underneath that is some standard XML. Looks pretty standard. We see that it's got some flags here that in fact this is RDF. And so this is our typical header. And as we go through the sections here, don't have any annotation properties, don't have data types, but we do have object properties. So here we describe a couple of our objects and what kind of properties they have. So we see that an object is pizza and pizza has base. There are some clarifications here that I won't go into. This happens to be a functional property and so on. But we can go through here and see the different kinds of objects and properties. Pizza has an ingredient. Pizza has a topping. So these are all statements that the ontology editor has created. And then as we go down here, we get to our classes. So we see that the American hot pizza is a named pizza. It has a topping. The topping might be pepperoni. It has a topping mozzarella. It has a topping tomato. It has a topping jalapeno. And we can go through this list and see all of the different statements that we've made. And so really, this entire program back here is just a way of illustrating what is in that RDF file, that XML file that's RDF and OWL. Now, one of the things that an ontology gets us is that because these are expressed as formal logic statements, we can apply some class reasoning to it. So if we go up here and we start the reasoner, this is going to go through and analyze all the statements in here that are made out of the RDF, and if there's anything in here that's inconsistent, then it can flag it. It can say, no, your logic is wrong. There's a problem with this here, and you can see down here that I've got an inconsistent topping I set up that actually has some properties that would not be possible in the context of this pizza, and so it's actually flagged this for us. And so this is the way that machines can look at statements like this. They can look at collections of statements. They can look at knowledge and begin to apply some logic and reasoning to it. And I think that's probably all we need to get at for this, but that gives you an idea of what the ontology is, how it relates to XML, and how it relates to RDF. So now let's talk about the semantic web. The semantic web is the use of ontologies, modeling languages, and so on to create a web of data. And if you think about the web as you normally might think about it, it's a collection of documents, and those documents are all human readable. And a lot of the specifications we talked about earlier in the lecture allow us as humans to find, analyze, and retrieve those documents. But now what we're really talking about is turning the web's collection of all this textual information, all this knowledge, and turning it into a standardized form of statements about the resources and about the knowledge that can be read by computers and applications. And you may have heard the term linked data or linked data movement. This is a movement within the semantic web to provide and describe methods that expose structured data for discovery by application. So the semantic web is really a way of turning the web, not changing it. We still want the web to be readable to us as humans, but it also creates a web of data that machines can actually use and understand. Let me give you an example of a project that is making this happen right now. If you think about Wikipedia, Wikipedia is the human-readable corpus of information about the world and things in it, and so it's very useful for people. We look up, we find out what information is there. We use and consume that information, but a machine can't really look up, a computer application can't look something up in Wikipedia and make sense of it. So there's a crowdsourced project going on now called DBpedia, which is Wikipedia expressed as an ontology. In other words, people are going in, they're taking these articles, they're taking all of the facts and knowledge and descriptions of the resources that are in Wikipedia and turning them into an ontology. So if you actually had a Wikipedia entry called pizza, the text might talk about pizza and pizza having ingredients and so on. And DBpedia then would actually be the expression of the ontology that we just looked at, that puts all of that into a formal semantic kind of a language that computers can understand. So we can take a look at two examples here. Let's take a look at the Wikipedia page for Berlin. And, of course, you're familiar with what this looks like. I probably didn't even need to go here. But you can see this has got a lot of facts in it. So one of 16 states of Germany, 3.5 million people, second most populous city. These are all kinds of statements or assertions that we can make about the content of this article and about the city of Berlin. And of course, this is of absolutely no use to a computer application, barring some experiments that are going on with artificial intelligence now, trying to figure out how to parse standard English. But this, in its current form, is not particularly useful for a computer application. So let's look at the DBpedia page. And the DBpedia page can be viewed. What it does is it takes the ontology and actually creates a somewhat human readable page. But you can see all the facts that are in here now, lists of facts. And what I'd like to do is actually view the page source, because I think that's going to be where you're going to see the XML and the OWL ontologies here. Okay, now you can see that we have our standard, and this is sort of a mix of HTML and XML. So you see that XHTML plus RDF is the version here. And we see the XML namespace declarations in addition to the HTML markup. And this is the header information. What I'm going to do, and there's a long list of these that are the abstracts that we saw earlier. But what I'd like to do is to get down to the actual facts themselves and show you what we're looking at. So if you look at the subject as Berlin, and we think about our RDF, we need a predicate, which is some kind of a property, and then we need a value for that property. So if the subject is Berlin, we have a predicate here, a property, DBpedia OWL. So again, this is an OWL ontology, and the particular property that we're looking for is total population. So this is our predicate. DBpedia OWL population total is our predicate. And then this is the XML namespace for DBpedia OWL. Remember, we mentioned namespacing earlier. And this is the location where this particular property comes from. And then we notice that the value for this property, this is the object, is the population total. So that should give you an idea of how this works, how we turn information that's human readable into information that's machine readable. Machines can come through, they can parse, that is, take apart all these particular things, and they can find these instances of the predicates or the properties and the subject, which is, of course, the Wikipedia page, and then extract all the values here. And this can now actually be used as part of a computer application. So that wraps up the lecture. That was a very, very high-level overview of the semantic web. I hope it gave you some idea of what's going on. It really is an important thing for information professionals, librarians, and so on to know about. We've looked at a couple of different things. Just to summarize, we saw how XML was used to organize resources for people to aid in discovery, evaluation, and access, and that allows people to find resources, read them, evaluate them. And then we also saw how, at the end, how XML and the semantic web was used to organize data for machines and applications to discover and analyze. And that's an important area for future research. If you're into knowledge organization and you're an information professional, then you need to know about those things. So I hope this was helpful. So thank you for listening. I hope you enjoyed the lecture, got a lot out of it, and will find it useful as you make your careers in the information sciences. Thank you.